طيب بسم الله الرحمن الرحيم. We continue with our chapter, introductory chapter. Okay, yesterday we looked at, or last session we looked at the approaches to secure cyber physical systems. Okay, and we said that there are some specific implementation that can be done to provide some security principles within CPS, and there are some principles that are let's say specific to CPS devices. And we said that sometimes when you do implementation of those principles, some implementation might affect the security principles positively or negatively. And we gave an example, for instance, barriers. We said the encryption, for instance, it is the main thing for confidentiality. We have 2+, and it does improve or does participate in providing also integrity, authenticity, non-repudiation, deterrence, delay, and neutralization. And it is affecting the availability, because when you do encryption to some data, that data will not be no longer be available to be read by the users. Okay, and you can apply it to any other types of implementation with the security principles. So this is with regard to some specific principles for CPS. There are other characteristics that needs to be available within CPS. One of them, which is known as a least privilege. Anyone, any idea, Shabab, about the least privilege?
As in only have the privilege you need and no more.
What does that mean?
As in don't give extra privileges that the user or the system does not need.
Yes, good. That means when you talk about least privilege, that means it is based on a role of the user. Okay, if you have a role, for instance, as for instance, an administrator, not an administrator, a simple user. Okay, that means you don't have, say, access to other type of actions that you will do and you will be able to do on the system. You will be limited to the role you have been assigned. Okay, and it is here when you talk about least privilege, usually it is related to what is known as mandatory access control. Mandatory access control, it is a way of control that is based on a hierarchical model. Okay, that means you will have some security level. When you talk about a security level, it is based on, have you heard about a clearance, security clearance, Shabab, or security clearance level?
Yes.
What is it, Shabab?
Yeah, it's a level that you get access to information that only that specific level can access, and no other level can access.
Barakallah. So this is usually this is one mean of the least privilege. To provide this privilege is to have mandatory access control. That means, as you mentioned, if you have, for instance, 3 levels, okay, and usually this type of access control, you can find it in military or government and military facilities, okay, where you do have access to some specific data or some specific file or system within that body, okay, and they are based on classification label. That means we have labels on those data. You might, for instance, classify and label some data being confidential. You can have some data can be, for instance, secret, can be classified or labeled as top secret. And if you do have a clearance, okay, the same clearance, for instance, user A has a clearance of confidential level. That means he has only access to any object or to any file or system that has been labeled as confidential. You will find someone who has a top secret label. He might only access the top secret label files or systems or object and so on. So this is means of the least privilege. That means you will access the data or you will access the system based on your role, and this should be available in any CPS. If a CPS, let's say a machine, for instance, has or need to access some processes in another machine, we should provide such least privilege. We don't allow any other machine to access another machine's processes or data, for instance. If you have users within a CPS environment, also those users should have that least privilege access, where they might or they can access only the CPS devices that they have been allowed to access based on their role. Okay, and of course, when you do, for instance, this type of access, which is mandatory access control, it requires from the administrator or the security guys who has set up such security level. It needs to have a careful planning and continuous monitoring in order just to keep all the resources, objects, and users classifications up to date. Because sometimes you might have someone now today who has maybe a confidential level or clearance. He is only, or for instance, today has a secret level or label. Maybe after a while, he will no longer be available to access such secret. He will be, let's say, decrease his clearance to a lower level, which is confidential. That means you need to be updated as an administrator. You need to update all such clearance and label of users who have processors or machines. But it is a very good way to control access and to provide the least privilege. Okay, Shabab? The other characteristic that needs to be provided, which is need to know. Here, when we talk about need to know, that means you are providing, you are adding more restrictions and authorizations to even for the authenticated users. Okay, when you do have, for instance, when you have access to any system, even if you provide your right credential, you provide your username and password, you are not automatically allowed to access anything within that CPS device. It will only access, it will not only allow you to access that specific part if your, let's say, your job needs to access that data to be done. Without accessing that data, your task or your job cannot be done. You will access it. Otherwise, you will not access. That means you will be limited only to whether your task and temporarily task. Sometimes now I will access. I have been assigned a task to update a folder. Okay, then I will do it now. I will have access to such folder. But maybe after 1 hour, the administrator will remove that task from me and assign it to another guy. That means I will no longer be able to access such data, because right now I do have the task and I need to know such data in order to do my task. But after 1 hour, I will no longer be responsible for doing such task. That means I will not have access to that data. Okay, because that's what we say. Your access is needed only as long as needed to accomplish your job. If your job doesn't dictate that you do have access to the data, you will not access such data. This is not as, or this is known as need to know. If we give an example, for instance, if you give, if you have, I think you have encountered that, for instance, when you install some application on your mobile phone or some apps, it will ask you, for instance, whether you are allowed to access the application needs to access your camera. Okay, and you do have options. Okay, always or when using the app or once. Okay, and think, for instance, you are using word processing on your mobile phone. You are typing. You are using word processing. Okay, and while you are typing a message or typing a document or editing any document within your mobile phone, the camera, okay, will be actioned, okay, and it will record your user. Okay, it will record that user who is typing let's say within that word processing on his mobile phone, which means of course we did allow the camera to search or to, let's say, to record some event on the mobile phone, but this is not the correct event. This is not the correct event that has been that will allow the camera to access or to record the event of typing from that user, even if you have allowed, okay, the camera to record some event, but typing or using the word processing, okay, is not part of need to know from that camera to be actioned and to record myself or the user while he was typing on his word processing, for instance. Okay, and this is what we mean by need to know. And sometimes you can find some companies that will agree to share their personal information. Okay, and they will share their personal information only maybe when sharing is in the interest of the person, let's say, from whom it was originated. So this is basically one of the characteristics that should be provided, that should be present in any CPS environment. It will allow to protect your environment. It will add an extra layer of security to just to enhance the security operation of any CPS devices and any CPS environment. The other part of security that is related to CPS, which is known as segmentation. Okay, when we talk about segmentation, this is a very important concept and characteristic with regard to securing a CPS environment. Okay, because as you know, as we have mentioned in our previous slides, that the CPS has become an emerging technology and fact for controlling so many connected or cyber connected devices, as we mentioned, because it is cyber and a physical part. Okay, and it has increased the use of many applications from many or different locations that will access and run those CPS devices. Okay, and also we did say that the CPS has provided the ability, for instance, to integrate such different type of systems, whether they are physical and cyber part. All those has, let's say, pushed the security to be adapted within the CPS environment, and by thinking about, let's say, how to enhance the security, how to apply such methods, okay, in order to secure the cyber physical systems environment. And one of them is known as segmentation. Segmentation means you are creating, as we mentioned in last session, if you remember, when we said we do have for the CYS405, we said about the gathering logical and physical IP address, for instance, or network information. Here the same way. Okay, when you define a physical barrier or logical barrier between, here we talk about between groups of devices and grouped according to communication functionality. It depends of, let's say, the criteria you are grouping such, you are creating such groups. Okay, you might create a group of device that are related, all the computers, for instance, that are related to computer department. This is one group. You might create the group of devices based on their functionality. I might have one group that does have, let's say, a group of servers, and those servers belong to different departments, but they have been grouped together in one group based on their functionality. We can do group based on the criticality of the devices, based on the highest risk to be hacked, for instance. So it depends on the way you choose to create those groups. By creating those groups, by separating devices, okay, or the CPS devices into groups, you are doing segmentation. And when we say separating, you might separate them physically. That means you will put them all together in one place that will secure that place, or you can create a logical segmentation. That means you will just group them logically, even if they are located at separate places and locations, but at the end they belong to the same group, or any security measures will be assigned to that group, will be inherited by all the members, or by all those devices that belongs to the same group at the same time. Okay, and the segmentation can be done, okay, by using subnetting, okay, by using encryption, by using virtual local area networks, by using access list or access controls. Like when you use firewalls, you specify which device will be allowed, which device will be denied, and so on. Okay, now what is subnetting, Shabab?
Is it cutting up the network into different domains within the same
Yes.
the same domain?
You are really approach. Yes, Faris?
With mask for each group of IPs.
Yes, subnetting, that means you will have different sub-networks. What is meant by sub-network? That means instead of having all the devices belong to the same network ID, let's say I do have big network 192.168.1.0. Okay, instead of assigning the IP address within the same network for all the devices, okay, what I will do, I will, instead of having one big network, I will divide my big network into small networks, and each small network has different IP or different network ID. For instance, the first one I will have 192.168.10, another one 192.168.20, 192.168.30. These are different networks with different subnet masks. Okay, and I will put the different devices and spread them into different networks or sub-networks based on, maybe as we mentioned, based on the functionality or based on the location. It depends on how you are going to choose how to group them. But when we say subnetting, that means we will divide one big network into small networks that are separated. Okay, but when we say small networks, that means we do have different separated network. Okay, like it's not like when you do have a switch. When you are using switch, you have one big network, because the switch doesn't divide, doesn't do subnetting, doesn't even deal with the IP addresses. We don't have such ability. If you want to do subnetting, don't call it subnetting. If you want to do grouping within switch, we are using VLAN. But here, when you talk about subnetting, that means I might use the routers, and each interface of the router is considered as a separate network. That means it does have its own IP address or its own network ID, different from the other networks existing or connected to the router itself. This is one way to accomplish segmentation. We can do encryption. When you do encryption, also we are separating data. We can have VLAN, as we mentioned. or virtual local area network. We can have it within the switch. We are dividing, we are providing subnetting. You can do segmentation. Sorry, here we talk about segmentation. Well, you can do segmentation by providing access control. When you do have an access control list, you will specify what is permitted, what is denied, that for any packet that will go through specific router, for instance, device or a firewall, you are doing segmentation because you are doing filtering based on some criteria. Maybe based on the source of the message of the packet, or based on the destination. It might be based on the protocol used. I will say any packet or any message that comes that is coming from TCP protocol port, for instance, port 80 or 53. I will allow it or deny it. That means here we are doing some types of segmentation. Any idea, Shabab? Software defined networking, SDN? Any guys? Any idea, Shabab? It's a new way of controlling the devices. In the normal network, you do have, for instance, when as we mentioned here for the access control list, okay, all the decisions related to whether to forward a message or to deny a message is done at, for instance, at the router's level, okay, to decide whether to forward the message or to deny the message or drop the packet. In the software-defined networking, that control part is not done at the level of the router. It is done at the level of another device that is called a controller, that is controlled by the user. That means the user will see the packet and the user will send a command to the router whether to allow or deny forwarding of such packet. That means all the control tasks will not be done and the decision will not be done at the router level. It will done at the control level that is controlled by a human. Okay, that means that router will only be used as a forwarder or denying the packet. That means all the control will be done separately from another device. So you will have more control granularity on those messages that are moving within your network. Okay, Shabab? And as we mentioned in general in the computing networking, the assets or the devices, okay, that needs to have to share some types of communication and to communicate to each other, they are sharing the same risk profile. Because if there is some devices that are communicating to each other, okay, if one device is compromised, the other one might be decompromised. And if you are classifying, we do have two devices or two CPS devices that have, let's say, the same level of risk. Okay, we will put them on the same segment because all those risky devices, okay, will have the same type of defense layers or the same type of policy and access control, for instance. Okay, and for those devices that don't need frequently to communicate between each other, we might put them in a separate network. Why? This is another way of, on top of securing the devices, when you put devices on the same segment, that means they will communicate. The communication will be done faster than communicating with another device that belongs to another segment or that belongs to another part of the network itself. Okay, as we mentioned, also we can we can split machines that have critical functions. Okay, we can make them across the network in different segments. For instance, okay, in order just to foolish, let's say, the hackers, instead of harming one accessing. If you put, let's say, for instance, I will put all those critical servers in one room. If that room is compromised, that means sorry, that means all the devices that are within the same room will be compromised. Here, one way of, for instance, creating segmentation, one idea of creating segmentation is to separate those devices that does have critical function. Okay, in order, if one is compromised or it is harmed, at least we are protecting the other ones. Okay, we are not giving a bonus to the hacker to do, let's say, to hack or to exploit, to let him access one place where he will find a bonus, will find all those critical servers within the same place. It's like you are using the same username and password for all the devices. If a hacker will manage to hack and compromise the username and password, he will have access to all the devices. And we need to have separate username and password for each device. In case of one of those devices has been compromised, at least we do have a protection. We are protecting the other devices. Okay, guys? Also, sometimes when we talk about the CPS communication, sometimes those CPS devices are communicating using the same network, and they might be at the different layers. Here we talk about different layers, like you do have, let's say, I do have computer department, computers. I do have accounting department, management department. All those can be considered as different layers, different locations. And we need to have some types of communication between computer departments and accounting department or the registration department. Okay, in such layers, or the existence of those layers, we are providing segmentation. And what we need to, as we mentioned here, we need to erect barriers between these layers. That means what I will do, I will have some types of, for instance, a firewall that will be used between the department location or computers and the management computers department, in order just to do filtering, because not all people or all users within computer department will have the access or permission to access management or accounting computers. Okay, and vice versa. So how we can do that? By erecting, by putting in place firewall between those two departments in order to do filtering. Okay, as we mentioned here, we are using control list. We can use firewall between those departments, between those different types of layers, okay, to do some filterings. When I receive message from a computer department that does have destination management or accounting computers or department, that request will go through access control list, and we'll see whether that access will be permitted or not. If it is permitted, it will let go that request, otherwise it will be prevented. Maybe I will allow only one computer with specific IP address from computer department to access the server in the accounting office. So I will specify within my access list that IP address of that computer, okay, and the type of the protocol, for instance, and I will do the definition of all the characteristics that will be based where, let's say, the firewall will do filtering based on those characteristics. Okay, this is where we do have the different or multiple layers of functionality that use the same infrastructure. When we are saying using the same infrastructure, that means we are using the same network of PSU university. Okay, the computer department and the accounting department are using the same infrastructure, the same network. Okay, but there are different layers, and they are separated by some devices that will allow to provide such segmentation. Here we are providing segmentation based on separating those layers of communication. Okay, guys? As we mentioned, also when we talk about allowing unregulated access between segments with different risk profile, allows opportunity. That means if you allow any user from computer department to access any device at accounting devices, accounting department, that means you are opening a barrage, you are opening, let's say, a hole for an attacker to access. But if you do segmentation by providing such filtering, you are preventing anyone from accessing anything from both departments. We already talked about the firewall or proxy to restrict communication. Here we talk about state-aware protocol. State-aware protocol, that means sometimes you will have some protocols that we talk about preventing senseless command combination. It's like, for instance, we give an example. You might have when the car is forwarding, okay, is moving forward, you will prevent any action that will trigger the transmission of the car to do the reverse. It's like, for instance, when you are driving, okay, driving your car, and someone will try to remove the keys from the ignition. And this is what we mean by preventing senseless command combination. That means in any, you will find some protocols that will, it's like they are intelligent protocol that will prevent any two actions that are opposite to each other. So let's say one action is move forward and the other action move backwards. Okay, these two actions cannot be done at the same time. Okay, this is one measures of preventing, let's say, of securing devices. Here we talk about, because we are talking about CPS devices, we are talking about intelligent card, and we are talking about a smart watch, smart devices. That means we need to provide such security in those protocols to prevent any opposite event or actions to be done at the same time. Clear, Shabab? Yes, guys?
Yes, clear.
Yes, doctor.
Okay. So I wanted to make sure that I am not just talking alone. Okay, another dimension of providing segmentation is by having access time. Access time is another segmentation or another dimension of segmentation. When you talk about access time, we are talking about restricting access to the devices at specific times. Okay, that means you will have some specific time that where you will allow some devices to be accessed, will have some processes to send their output to other processes. This is one way of providing segmentation. Okay, verbally or virtually, when we set the time to access the device to run some specific processes in a machine, okay, we know that machine should run that specific process only between 8 to 12. Okay, we are providing something that looks like a segmentation because we are not allowing that process to run any time. We can have also, for instance, as we mentioned, based on the user role. Okay, when you do have when you specify the role of the user, that this user should do this and this and this, we are providing some types of segmentation. Okay, and as we have mentioned previously, when we use the MAC, okay, which is based on the role-based access control. Okay, based on the groups, as we mentioned, you might group devices. You might group users based on their functionality to perform some specific job, for instance. Okay, or one machine can be it might be workstation and server at the same time. Okay, you can do some types of segmentation based on what process or what action that device can do. It might now act like a workstation, or it might act as a server. It might act as both workstation and server at the same time. This is another way of providing segmentation. We're going to stop here. We continue, inshallah, for the next session. Do you have any questions, Shabab?